We want to convert this expression into a single number in complex exponential form. This part of this expression consists of three complex numbers, all of which are in rectangular form. 2j plus 2 is multiplied by 3j minus 1, and that whole number is divided by j plus 2. Now, multiplication and division are most easily done in polar coordinates. So my knee-jerk response is going to be to convert each of these into polar coordinates, do the multiplication and the division. Now I add that to a number j. Addition and subtraction are most easily done in rectangular coordinates, so after I evaluate this whole expression here, I'm going to convert it to rectangular coordinates and add j to it. Then I'll need to convert that whole thing back into exponential form. So the individual components, 2j plus 2 converted to polar form is the square root of the real part squared plus the imaginary part squared. E to the j inverse tangent of the imaginary part, which is 2, over the real part, which is 2. That number is going to be up in this first quadrant, so this will be 2 square root of 2 e to the j 45 degrees. Now I'll convert the number 3j minus 1 to polar form, so it's got a magnitude of the real part squared is negative 1 squared plus the imaginary part squared is 3 squared. E to the j, it's got an angle of arctan of 3 over negative 1. If I check the quadrant on this number, the real part is negative 1, the imaginary part is 3, so I'm going to be over here in the second quadrant. So if I simplify this, this becomes the square root of 10 times e to the j 108.4 degrees. Now let's go ahead and do j plus 2. So in polar form, j plus 2 is going to become the square root of 1 squared, the imaginary part, plus 2 squared, the real part squared, e to the j inverse tangent of the imaginary part is 1, the real part is 2. That number is going to be in the first quadrant, so this will become square root of 5 e to the j 26.6 degrees. So now this whole expression here, if I evaluate that in polar form, will be 2 square root of 2 e to the j 45 degrees times 3j minus 1, which we said was square root of 10 e to the j 108 degrees, well 108.4 degrees, divided by j plus 2, which is square root of 5 e to the j 26.6 degrees. So multiplying this number by this number, I multiply these two magnitudes together, then dividing it by this magnitude, so this becomes 2 square root of 20 over the square root of 5 e to the j. I add this angle to this angle and subtract this angle off. That becomes 126.8 degrees. Now I need to add that to j. That's going to be most easily done in rectangular coordinates, so I'm going to take this and convert it back to rectangular coordinates. Just as a quick review, if I have a set of real and imaginary axes here, and if I have a number in polar form which has a magnitude of a, distance from the origin, and a phase angle theta, the real part of this is going to be magnitude of a cosine of theta, and the imaginary part will be magnitude of a times the sine of theta. So this number turns into a magnitude 2 square root of 20 over square root of 5 cosine of theta, which is 126.8 degrees, plus the imaginary part is 2 square root of 20 over square root of 5 times the sine of 126.8 degrees. And this becomes negative 2.4 plus j times 3.2. Now I add j to this, so plus j, this becomes negative 2.4 plus j 3.2 plus j is j 4.2. That's a perfectly legitimate answer, except that it's in rectangular coordinates instead of the complex exponential form we want. So let's make a little bit more room here. So converting this number to polar form, the magnitude's going to be the square root of the real part squared, which is minus 2.4 squared, plus the imaginary part, which is 4.2 squared, e to the j inverse tangent of 4.2, which is the imaginary part, over negative 2.4, which is the real part. If I simplify that, that becomes 4.84 e to the j 120 degrees. And there is my final answer.